Hey everyone, this is FixReef. Today is the Radion repair day, and so now we have this XR30 Gen4 up for repair. The problem with this, the stated problem with this light is that it shuts off at high intensity. Overall, it doesn't look too bad. The lens is nice and clean. I can kind of see the LEDs inside, fairly nice and clean. Yet it's supposed to shut off when we provide higher intensity, somewhere over 50% intensity. It just shuts off, and the lights on the back, the button lights, start blinking red. So right now they're blinking white because we don't really have any power attached to it, but I already have USB connected, so that's why they're blinking like this. So let's find out what's wrong with it. First, we'll begin with the diagnostics, and we need to show when exactly it's going to shut off. Before I even take it apart, I just want to know what do I need to do to reproduce the problem. So I'm going to give it full power. Let's lower the brightness a bit so that it's not in the eyes. Something like that. And let's take a look at the LEDs that are on currently. Tell that the UV LEDs are on, the blues are on, the reds, the greens, the whites, the yellow, royals on both sides are on fairly good shape. Everything is consistent, about the same intensity. However, we can tell that on both sides, the violet lights, this violet and this violet, this violet and this violet, are completely off. These are likely that's likely the channel that's causing us trouble. Let's turn everything off, every single channel. And let's try about 50% intensity, and I'm going to bring up each channel individually. Here's red, it's on. Green, that's also on. Warm white or yellow, that's on. Cool white, should be pretty bright. All of them are on. Regular blues are on. Royal blue, all of them are also on. UV, all four on each side are on. Now I'm going to bring violet up. Number one, violet is now at 100% intensity and nothing's happening. And let's see if we get, and nothing is showing on these buttons, so the light is still white. So now we're gonna bring up the intensity to the brightness to 100%, and at 100% with just violet channel on, it starts blinking, looks like teal and red. At this point, this light is in a state where it's trying to preserve itself and not continue lighting up, indicating that there is a problem. There is clearly an issue with the violet channel. So let's shut it off. Now that we know how to reproduce this, we're going to shut it off entirely, including the USB, and we're going to find out what's wrong. Okay. Well, I can tell right away that we are probably going to have a problem with the main board. I'm not sure to what extent you can see this. Let me actually zoom in. but it looks like there is some salt damage on these components. There is this white hue all over the place here. Let me see if I can zoom it in. Yeah, you can see that all of this is covered in salt, potentially damaged. But before we move on to the board itself, I would like to actually test the violet channel individual LEDs just to make sure that those LEDs actually work. Because if they work, the problem is with the main board. If they don't work, there is also a problem with the LEDs themselves. Alright, so to test those, I'm going to switch over to the diode test mode on my multimeter. And just in the diode mode, it's going to provide a little bit of power to each individual LED. It's not enough to burn it, but it's just enough to see if it lights up. For example, we know that, say, the red channel is working. So we can try to test this red LED, and we can tell that it lights up. Okay, equally, this violet is supposed to light up if it's working. And it's working. This one doesn't seem like it's working. What about this end? I'm not seeing it's working. And this one is working. So this one works. This one works. This one does not. And this one does not. All the other ones light up. So the starting point is probably going to be these two LEDs on the inside. It's very interesting that they're so symmetrical in the way how they work or don't work. The outside work, the insides don't. Well, I think I've seen enough. Looks like these two LEDs are going to have to be replaced. All right, so before we go on to replacing anything, let's take a look at the main board as well. All right, so the board is finally out, and let's take a closer look. The underside of the board is actually not looking all that bad. I don't see, with just my eyes, I don't see a whole lot of corrosion. Maybe a little bit around the USB, but that's very typical. I do see a little bit of corrosion over around this area. Let's take a look at it under the microscope just to see what we've got in case it does need an ultrasonic cleaner. There's definitely corrosion on a couple of channels. This one is mostly clean, but this has some corrosion. This has a lot more corrosion, and this has some corrosion. So 3 channels. Let's take a look at this one as well. The rest looks good, but a couple of these channels are definitely corroded. So this will need to be ultrasonically cleaned. Alright, so this board is going to go through the ultrasonic cleaner, and I will be right back. Okay, so while the main board is going through the ultrasonic cleaner, we're going to attempt to fix the violet channels on both of these LED modules. So to do so, first we need to remove these two LEDs. So I'm going to apply a little bit of flux around each of the LEDs. I'm going to take it away to my reflow station and have those LEDs removed. And I'll be right back. Both modules are back from the reflow station. LEDs have been removed. Now we just need to clean this area up. And I'm going to remove all of the unleaded solder and put the leaded solder back in place and put the new LEDs back in. So let's clean this up. Now I'm gonna add some leaded solder, enough to be able to attach the LED and then potentially clean things up a little. Now that everything's cleaned up and reset, we're gonna need to get a couple of violet LEDs and install them. All right. Let's get a couple of these guys. Should be direct replacements. And this is the position for that. The reason I keep them kind of away from the pads yet is because I do need to add some flux. Because remember that the LEDs are now completely dry, have no solder on them, nothing. So for things to work, we'll need to add some flux. And off to the reflow, and I'll be right back. Okay, so the LED modules are back from the reflow, and the easiest way to test them now to make sure that all of the violet LEDs are working now is to actually use this test pads here. So for instance, this test pad over here tests green channel. So both of the green LEDs come up. We can test the violet from over here. You can see that both of the violets are on. So that works. Again on this one, this is green and it works, and this is violet and it also works. So we now fixed both of the violet channels. So all we need to do now is just clean up the mess around the LEDs and see what's next. Okay, while the alcohol is drying, one last test for the violet channel. On and on. And we're officially done with the LED modules for this light. In the meantime, the board is done with the ultrasonic cleaning. Visually, it looks pretty nice. Definitely the most of the whitish hue over on this side of the board is gone. There is still maybe a little bit may require additional manual cleaning, but doesn't look too bad. I haven't tested this board yet. It's done with cleaning. It's dry. We are going to take a look under the microscope to see what was under the salt, because typically what happens is that when you have the salt creep for a long time along smaller components on the board, it starts eating away from those components, and it may eat away solder, it may eat away copper, it may eat away a bunch of things. So we need to make sure that it's all still intact there and fix if there's anything that's not. Let's take a look. So here's our board under the microscope. This board has 8 channels. Each channel is represented by a series of MOSFETs and OpAmps. So there's a MOSFET, there's a OpAmp, a couple of transistors. These components over here are the current sensing resistors. Those are extremely important. So this set of circuitry seems pretty good to me. Maybe a slight corrosion on the metal here, but it's nothing to worry about. The next set looks a little bit worse, but most of the salt's gone. Maybe a little bit left here and there that requires a little bit of scraping, but for the most part it's all clean. Everything is still intact. I'm not seeing any corrosion on this board parts. Everything here looks pretty good. Nothing's moving. All of the resistors and capacitors are in place. So far so good. This was the worst corroded area when we got it. Still a little bit of hue here and there. It's not particularly horrible, but let's test some pins. Nothing's moving. Oh, wait a minute. Okay, I guess let me zoom in so that you can see there is definitely a problem with this OpAmp. Dual channel OpAmp. You can see that it's lifted. It's lifted. Each pin on this side is not connected. The pins on this side are still connected, but this pin is completely lifted, which means that the salt corroded away all of the solder and some of the metal and completely disconnected this unit. Why don't we just go ahead and replace this whole OpAmp with a brand new one, clean up the pads underneath, make sure that the connection is going to be nice and solid. Alright, I'm going to use my hot air to replace this, but first there is not much to remove, only one side of it, so let's put a little bit of flux on this side. And it's gone. Now that it's gone, it's extremely important to clean up all of the pads. And this we can do with a regular iron with a big tip. As you can see, one side is nice and clean because corrosion didn't get to it too much. The other side is corroded significantly. Looks like the resistor is also moving, so that will have to be fixed as well. Okay, now all of the OpAmp pads are nice and clean. Let's get this all nice and clean as well. Beautiful. Good news is that none of the pads have actually corroded away, which means that we can easily, or we should be able to easily solder new components back on. Bit of cleanup just to see what we got. Oh yeah, this is definitely still very good. Now I can just put solder back on those pads. Very good. Okay, with the damaged components completely removed, we're going to, we could, technically speaking, take the original OpAmp and try to put it back in place. The problem is that all of the pins on it are corroded and they may not have a good contact, and I'm not feeling like, fixing them at this point. So I'm just going to go ahead and get a brand new OpAmp and install it here. Okay. Well, before I install the OpAmp, let me put the resistor in place first. Okay. Okay. And I will adjust it with my hot air in a minute. But this is looking real good. And now the OpAmp. Perfect. Check all of the pins. Oh yeah, everything is super solid now that it's done. Okay. All right, so the circuit is fixed. Hopefully, both of the LED modules are fixed. I think it's time to attempt to test this. All right, so this is going to be the first basic test. I just put together the two LED modules, the RF module, and the main board that we just fixed. So if we attempt to power it up briefly, it should come up, but it should then shut off because I'm not giving it enough power to run it at full speed, and I don't want to do so because currently there are no heat sinks attached to those LED modules. So let's take a look. And the lights came on and then turned off. Perfect. So far it looks like all of the LEDs are working. Let's put it back into the enclosure. At that point, we're going to be able to give it full power and see if it stays lit. All right, so the light is partially assembled. Once again, I'm going to give it a little bit less power just to make sure that it's in assembled state. It will come on and then shut off again. Looks good. Finally, we are going to give it full power and let's see what happens. We're now consuming about 5 amps at 36 volts. Stay in lead. All of the LEDs are on, including the violets. All is good. All right, so it looks like this light is mostly fixed. I will have to reassemble. I will actually have to add proper thermal paste on both of this under both of these LED modules, assemble everything, tighten everything, actually test it, make sure that the communication works, make sure that the USB still works, make sure that it actually stays lit long enough for some time before I call it a complete repair. But at this point, it looks like this light is fixed. Once again, to review what we've done is that it turns out that there was quite a bit of corrosion on the violet channel of the main board. So we had to clean up the main board, remove all of the oxidation. Once we removed the oxidation, it turned out that one of the OpAmps was disconnected from the board. We replaced that, cleaned everything up. This corrosion probably caused the violet LEDs to burn out because, again, they're very symmetrical in the way how they burned out. It's not random, so had to replace both of those LEDs, and that fixed all of the problems with this light. If you enjoyed this video, please like and subscribe, and I will see you next time.